My dear students, we will look at the design of decoder which is having active low inputs and active low outputs. So there is an enable input which is active low, and we have set of outputs, for the decoder D0, D1, D2, D3, D4, D5, D6 and D7. These are also active low outputs. In inputs, only enable is active low, whereas A, B, C are active high. For such a decoder, we would like to look at the design. So what exactly design? Design of decoder requires, what exactly this design requires? This requires input and output details of decoder. So what exactly input output details of the decoder? Input output details of the decoder is nothing but truth table. So we will look at the truth table. So in the truth table, what exactly we will have? We will have set of inputs and the outputs. What are the inputs? A, B, C. Enable input. Enable is active low. A, B, C. We have D0, D1, D2, D3, D4, D5, D6, D7 outputs. So D0, D1 up to D7 are represented here. When enable is 1, what is meant by enable is 1? When enable is 1, your device is, what exactly is device? Decoder. And enable is 1, all outputs are 1s. Why? Because active low. What is meant by active low? When it is active, output will be low. When it is inactive, output will be high. So high means R or inactive because it is not being enabled. Because enable is active low, input is given 1. So this is not activated. That means all outputs are 1s because it is active. So does not matter ABC values, all outputs are 1s. For 0, 0, 0, 0, D0 is 0 because input is 0, D0 is 0 and circuit is enabled, so it is functioning, that is D0 is 1, rest of them are 1s. When for 0, 0, 0, 1, when input is 0, 0, 1, enable is 0. So when all enable, always this circuit is working when enable is 0. When enable is 1, irrespective of the inputs, all outputs are 1s. When particular input is given, that particular output, that means if we give 1, D1 is 0, if we give 2, D2 is 0, if we give 3, D3 is 0, if we give 4, D4 is 0, if we give 5, D5 is 0, if we give 6 as input, then D6 is 0, 7 is 7 is 1, 1, 1 with enable equal to 0, then 7 is 0. So this is what exactly input relation is. From these input-output relations, what exactly we can do is, we can write what exactly outputs are. Outputs are D0. D0 is function of enable A, B and C. Similarly, D1 is function of enable A, B and C. Likewise, up to D7, which is also function of enable A, B and C. So from this, what exactly we try to do is, we write the expression by looking at the table. Now what we are doing, this is 0. 0, I need to get it from enable A, B, C. So when enable is 0, A is 0, B is 0, C is 0. So D0 is nothing but, because I am writing with respect to 0. When I write with respect to 0, we will get a max term. So what is that? Enable plus A plus B plus C will give you 0. How can I write this? This can also be written as enable bar plus A bar plus B bar plus C bar whole bar. If we expand this from using De Morgan's law, okay? So when I remove this complement, add becomes R. If there is a complement, remove the complement. If there is no complement, put a complement, because all are having complements. When I remove this, okay, enable plus A plus B plus C. So this is nothing but this. Similarly, if I look at for D1, it is 0, 0, 0, 1. So it is enable plus A plus B plus C bar. Why C bar? Because I want 0, I want for D0. whereas C is 1. So I am writing expression with active low logic. I am writing active low logic. When I am writing active low logic, enable plus A plus B plus C bar. Likewise, I can write for D2, D3, D4, D5, D6, D7. For example, if I take D7, what exactly is 0, 1, 1, 1? How you get 0 from 1, 1, 1? Complement and R. So enable bar. So this is enable is 0, A bar plus B bar plus C bar. So this will give you D70. This can also be written as this. So one can implement directly using OR gate or can implement using NAND gates. Right? So by using 4 input OR gate or 4 input NAND gate, you can get D0, D1, D2, D3, D4. Only thing what I need to do, I need to draw circuit. How exactly circuit will be? 4 inputs. Output. This output is D0. Next, 4 inputs. Output D1. What are the inputs? Enable bar, A bar, B bar, C bar. What about this? Enable bar, A bar, B bar, C. What about next? NAND gate, NAND gate. It is the NAND operation, right? NAND gate, similarly D2. So for D2, what exactly? Enable bar. We look at this expression because when I implement this, these are AND gates. So D2, for D2, enable bar, A bar,